I'm Eve Donnelly, and I'm the PI in the Donnelly Lab.
Hi, I'm Sara Sacher. I'm a second-year master's student in the Donnelly Lab. My current research focuses on investigating why patients with type 2 diabetes have a higher risk of fracture than patients without diabetes. In particular, I look at examining the relationship between the microarchitecture of the bone and how damage forms microscopically. So currently and conveniently, given the state of the world right now, a lot of my work is computational and easily done remotely. So I'm performing image analysis of high-resolution images of bone in order to look at and quantify the formation of damage on the bone. So I'm also performing an experiment using high-performance liquid chromatography to quantify the existence of harmful crosslinks in the bone that might also contribute to this higher fracture risk. So I decided to join the Donnelly Lab because I really wanted my research to focus on the intersection of material science and the biomedical field. And also I just really enjoyed the atmosphere and the people who were a part of the lab, and I definitely think it was the right decision.
Hi, I'm Lei Chen, a second-year master's student in Donnelly Lab. I come from Shanghai, China, and I majored in material science and engineering when I was an undergraduate. That is the same department as what I major now in Cornell. My research is a collaboration with Dr. Rizink, who is an orthopedic surgeon from med school. We are trying to understand a mystery: what is the main factor that leads to the catastrophic fracture of racehorses' bone in their legs? So, in order to investigate the fatal injuries in racehorses' bone, I will use Raman spectroscopy to analyze the bone compositional information. In addition, my current work will also include developing custom codes to analyze the spectra I collected. Another research will be focusing on how to predict fragility fracture and failure of spine fusion surgeries. So I will use the nonlinear optical microscopy to investigate how degeneration of collagen will affect bone fragility. In the coming next semester, I will be focusing on collecting and analyzing images of collagen fibers and fluorescent crosslinks. Biomedical field is somewhat mysterious but close to our daily life, which is extremely fascinating to me, and that's why I decided to join the Donnelly Lab.
Hey everybody, I'm Eric Taylor. I'm a 6th-year PhD student in mechanical engineering from Warriors Mark, Pennsylvania, just outside of State College, Pennsylvania, where I attended Penn State University majoring in material science engineering. Our research focuses on how we can use traditional materials characterization techniques such as FTIR and Raman spectroscopy to measure the structure and properties of bone tissue to assess changes with disease, age, and drug treatment. Over my time in the Donnelly Lab, I have gained expertise in FTIR and Raman spectroscopy, X-ray diffraction, gravimetric analysis, and elemental analysis. I've also used TEM and traveled to Brookhaven National Lab to perform tender X-ray spectroscopy experiments. Current experiments in the lab that I'm working on consist of collecting large polarization-resolved FTIR images of cortical tissue from patients who have experienced a fracture or who have not, in order to elucidate the role of collagen and mineral orientation on fracture risk. On a day-to-day basis, I spend most of my time developing code to process and analyze data sets of FTIR and Raman spectra collected in chemical standards and native bone tissue. Additionally, I spend at least an hour each day reading papers in the fields of applied spectroscopy and bone material characterization to assist with writing manuscripts. I decided to join the Donnelly Lab based on my interest in the mechanisms of toughening and hierarchically structured materials.
Hi, welcome to Donnelly Lab. Come take a tour.
So this is our general lab area. We have a lot of key equipment here, like our HPLC machine, a microplate reader, and down there we have a lot of equipment that we use to prepare bone specimens.
Shown here is our Fourier transform infrared imaging system. It's one of the most important techniques that we use in our lab. It couples an infrared spectrometer, which uses light to measure the chemical species in our specimen, to a microscope, which generates
graduate student has a desk, and we have computers where we use shared software, and we also have a whiteboard where we work out experiments that we're currently working on.